So now that all of this is clear, let's head on to the most important part in the data science life cycle, which is machine learning. So to understand machine learning, let's go through this simple example over here. So what do you actually see in this slide? What is this? This is a fish, isn't it? And what about this? Well, this again is a fish. And this? Well, this too is a fish. Now my question to you folks is, how do you know all of these are fish? Well, as a child or when you are in kindergarten, you would have been told by your kindergarten teachers or your parents that this is a fish. You would have been shown an image of a fish, a picture of a fish, or you yourself maybe had an aquarium at home and you would have been told by your parents that this is a fish, and your brain learned that this is a fish, and that is how our brain functions. So now let's say you grew up, and whenever you again see a real life fish or an image of a fish, your brain automatically registers this entity or this object as a fish, and you immediately know that this is a fish. But my question is, if I feed these images of a fish to a computer or a machine, how will it know that this is actually a fish? So we'll apply the same thing as we had done with our brain. So our brain was fed information. It was recurring information. So we were told as a child, we were shown this picture of a fish, and we were told again and again that this was a fish, and our brain processed it. So our brain, first looking at the picture of the fish, it processed all of the features of the fish, and then it also associated this tag. So the tag was FISH along with this object of fish. So we'll do the same thing over here. What we are going to do over here is, we will be feeding thousands or maybe even lakhs of images of this fish to this machine until it learns all of the features associated with these. So we are training this machine to learn that a fish will have fins, a fish will have two eyes, a fish normally, it has an oval shape, it has a tail, fish normally is found in water. So these are all of the features which are fed to the machine, and this phase is known as the training phase. And once the training is done, we will give it a new image, or we will give it test data to determine how much it has learned. So here we are giving this machine new data or test data, and if it is correctly able to tag it as a fish, then it would mean that the training is successful. So this is the underlying concept of machine learning. So what we do is, in the training phase, we train the machine with all of the data so that it learns the features associated with the data. And once it learns all of the features associated with the data, we will give it a new data or test data to determine how much it has learned. So that was a brief about machine learning. So now that is clear, let's look at the different categories of machine learning. So machine learning can be broadly categorized into supervised learning and unsupervised learning. We also have another category called as reinforcement learning, which we'll be skipping for now. So you can consider the main categories are supervised learning and unsupervised learning. So we will start off with the first category, which is supervised learning. So in supervised learning, we will have an input variable and an output variable. The input variable is denoted with X and the output variable is denoted with Y, and we try to determine how does Y vary with X, or how is Y dependent on X. So this, what you see over here, Y is equal to function of X. This basically means that X is your independent variable and Y is your dependent variable. So the names are very intuitive, isn't it? We call X as the independent variable because this is what influences Y. And since Y is dependent on X, we call this as the dependent variable. So this in supervised learning, just understand that you will have an input variable and an output variable. The input variable is known as the independent variable and the output variable is known as the dependent variable. So now that that is clear, supervised learning can again be classified into two parts. You will have regression and classification. So let's start off with this category, which is classification. So classification is a supervised learning category, and with the help of classification, we try to predict the class of a new variable. So here we have this example. We are trying to predict or classify if someone has cancer on the basis of whether this person smokes or not. So here smoking will be your independent variable and having cancer will be your dependent variable. So on the basis of whether the person smokes or not, we will classify this patient as having cancer or not. So here also when it comes to classification, you would have to remember that your dependent variable is categorical in nature. So when I say the variable is categorical in nature, what I mean is you will have different categories. So either this could be a binary classification or it could be a multi-layered classification. So here what we are doing is just a simple binary classification. So in binary classification, you just have yes and no, 0 and 1. You basically have only two categories, either this or this. So here, consider that you have maybe around a list of 1,000 patients and you have a column which will tell you whether this person smokes or not. So that column has only two levels, which is yes or no, which is for whether the patient smokes or not. And on the basis of that, you are trying to classify whether this person has cancer or not. So this is an example of classification, which is a supervised learning algorithm. Then going ahead, we will have regression. So regression is used to estimate the relationship between different entities. So since again, this is a supervised learning algorithm, you will again have a dependent variable and the independent variable, and will basically try to understand the relationship between the dependent variable and the independent variable. So under regression, we have this technique called as linear regression. And in linear regression, you have to keep in mind that your dependent variable should be a continuous numerical. So this is where you will have the difference between a classification algorithm and the linear regression algorithm. So when it came to classification, you will see that your dependent variable is a categorical variable. It is categorical in nature. But when it comes to regression, your dependent variable will be a continuous numerical. So let's take this example to understand linear regression better. So let's say you are doing a case study in a bunch of college students where you're trying to understand if there is any relationship between the CGPA of the student and the GRE score of the student. So let's say some of the students of this particular college are trying to go for their masters, and to go for masters you would have to give this exam called as GRE, and they would have given the GRE exam maybe in their final semester or pre-final semester. So here you have two variables. Your Y, your dependent variable would be your GRE score, and your independent variable would be your CGPA, because I am trying to predict the GRE score of the student on the basis of the CGPA. Now, let's say if I have collected all of the data of these students and I have two columns over here. one column will tell me the GRE score of the student and the other column will tell me the CGPA of the student. So what I do is I map the CGPA of the student on the x-axis, so because it is my independent variable, and I map the GRE score of the student on the y-axis because it is my dependent variable. And if I plot all the points, I will get this straight line. So this tells me that there is a linear relationship between the GRE score of the student and the CGPA of the student, which basically means that if the student has higher CGPA, it is more likely that he will also get a high GRE score. So that is something which we will be getting from this graph itself. But what if I change the question? What if I ask you if the CGPA of the student is 8.3, what will be the GRE score of the student? How will you answer this? So this is where linear regression comes in. So in linear regression, consider this to be your straight fit line. So with the help of the straight fit line, let's say if the CGPA of the student is 8.3, let's say 8.3 is somewhere over here. I will draw a straight line from over here to here. I will draw a vertical line like this. And now from this point, I will draw a horizontal line onto the y-axis. So let's say from here to here, and the value comes out to be around 312. So this basically means that if the CGPA of the student is 8.3, then the GRE score of the student would be somewhere around 312 or in the margin of 310 to 315. So this is something which we can predict using linear regression. So this was all about our supervised learning techniques where we had regression and classification. Then we will go ahead and understand about unsupervised learning. So in unsupervised learning, you will have to understand that you will not have dependent variables or independent variables. You will just have data points without class labels. So you will not have tags associated with your data points over here. So in this particular example, we have all of the data points where we have cars and bicycles together without the labels. Just consider that we have the images of cars and images of bicycles, but we do not have the tag associated with it. So when I say we don't have the tag, so we'll not have a label which will tell you that this is a car or this is a bicycle. So now what we will do is we will go ahead and build an unsupervised learning algorithm on top of this data. And when we build this unsupervised learning algorithm on top of this data, this algorithm automatically divides this data into two clusters. The first cluster comprises of all of the cars and the second cluster comprises of all of the bicycles. Now, even though there were no class labels associated, this unsupervised learning algorithm was able to divide this data into two clusters. And this was possible because an unsupervised learning algorithm helps you to understand the underlying structure of the data. So here, you would have to keep two things in mind, which is intra-cluster similarity and inter-cluster dissimilarity. So when I say intra-cluster similarity, so if you look at these three data points inside this cluster, you will see that all of these three data points are very similar to each other. Similarly, if you look at this second cluster over here, you will see that all of these three bicycles are very similar to each other. But when I compare the data points of cluster 1 with cluster 2, you will see that both of those data points are very dissimilar. So cars are very dissimilar when you compare them to bicycles. And this is what is known as inter-cluster dissimilarity. So this is how an unsupervised learning algorithm works.